Hi everyone, we are finally ready to present Labyrinth I, a game that my group has been actively working on recently. In this video, we will be discussing highlights of our gameplay and also explain the technical details. To begin with, our game is inspired by Sokoban, a puzzle game where players push boxes within a maze-like map into designated storage spaces. We created ours with a unique story background and integrated the mechanisms and random events we designed. Our game is designed for players to use the 4 arrow keys to manipulate the character, and also players can press T to display hints, C to skip the animations, E to exit at the door only, R to restart the level, and P to skip only for the tutorial. Now let's dive into the gameplay, where I will be illustrating how to play our game through the tutorial level and using examples from it. As you can see from the guidance on the right, players need to move Candy to sorrow and courage to fear to alleviate the emotion. After they have been matched, players can go to the door on the top right and press E to continue to the next level. Here in level 1, in addition to moving Candy and Courage like the last level, players need to match Hope to Doubt and Calm to Everything. There can also be unauthorized random events and disruptions, as illustrated by the player teleportation. As per usual, players need to proceed to the door and press E to continue to the next level. In level 2, there will be obstacles as represented by the region with skulls. Players need to remove them by matching the other antidotes first to their corresponding emotions, then to unlock their access to the last antidote, which is Hope. Then, find the door and press E. As you may have noticed by now, the game's difficulty increases substantially while it progresses. This is level 3, and it has a unique mechanism. Players are recommended to manipulate the antidotes in the middle area first to remove the barriers that are represented by dashed lines. Then, mash the antidotes in the lower right region to remove the rest of the barriers. This way, players can unlock access to the whole map and complete the level. Lastly, head over to the door, which will be unlocked once everything is complete to finish the game. Now, I'll have my teammate discuss more about the technical implementations of our game.
Hi everyone, let me introduce the technical implementation of Labyrinth I. Thanks to the built-in curses library, in Labyrinth I, we have lots of dynamic color ASCII arts. We first set up basic curses configurations like color pairs and window size, which are essential for animations. With a simple for loop and the settings, we can display an ASCII text with dynamic colors. For example, the level 1 title here. Using the same approach, we can draw other animations and game contents. Object-oriented programming plays a key role in our development. We mainly use 3 classes: boxes, character, and define level map. We create different instances of these classes for the gameplay, and thanks to OOP, we can reuse code, avoid repetition, and develop faster. One important function I would like to highlight is the draw map. Each number in a nested list represents an ASCII symbol, and by looping through the list and adding strings to the window, we can display the whole level map. We also develop many other functions that in our class instances can use. Here, I would love to share the core technique in our game, which is how we handle our user input and make it reflect correctly on screen. When a player presses a key, we need to make sure that the character and antidotes react properly to the environment. First, our check character box relation function compares the coordinates between the character and antidotes, decides whether the character can push or not. As shown in the picture, when the character is 3 units away from an antidote, a push may happen. But it's not that simple because collision with walls also happen. Our check walls function checks the next 3x3 area to see if there is a wall and stops movement if needed. We also handle more complex cases like pushing one antidote into another. In that case, both will stop. And also, for the partial collisions, when objects partially collide with each other, neither will move. And in the final step, all individual checks are combined into one comprehensive validation function called Move Character Box, which ensures that the user inputs are correctly reflected on the screen and the character and antidote movements remain within valid boundaries. And the best part is, in each level's code, only one line can trigger all this logic. Overall, Labyrinth I combines the power of curses, object-oriented design, and smart validation logic to create a smooth, dynamic ASCII game. We hope you will enjoy it. Thank you.